Under the previous concept, I am going to explain the problem. Two weights 80 Newton and 20 Newton are connected by a thread and move along the rough horizontal plane under the action of a force of 40 Newton applied to the first weight of 80 Newton as shown in the figure. The coefficient of friction between the sliding surfaces of the weights and the plane is 0.3. Determine the acceleration of the weights and the tension in the thread. Use work energy equation. That is what you are explained in the previous one. And the same problem we discussed in the last chapter without changing the number. The coefficient of friction of the blocks is 0.3 and you have to find the acceleration of the blocks and tension of the string. So as said earlier, I am going to draw the free body diagram of both the plugs. I am not draw the free body diagram separately. So you are very familiar that the free body diagram, 20 Newton of the block 2 downwards, stacking 2 downwards. This is a normal reaction. You know, both normal action weights are very similar. So upward forces equal downward forces. So 20 Newton as a normal reaction. Same as here 80 Newton weight acting towards downwards. The normal reaction inverse weight acts, normal reaction acts upward direction. So the force P is acting in the rightward direction. Here the tension of the blocks. These are the two are the frictional forces because the blocks moves in the rightward direction, the frictional block moves in the leftward direction. The frictional flux Fm is nothing but you know mu into Nr, mu into Nr, this is Nr. The two things are Nr, so mu into Nr, mu into Nr, I am right. Now, summation of all the horizontal forces. I said very clearly we have to consider only the summation of horizontal forces. So, horizontal forces equal to 40 Newton minus 0.3 into 80 minus 0.3 into 20. Now finally we obtained the value of 10 Newton. No need to consider of tension in the string because I said very clear the internal forces of the work energy is 0. So we need to consider the tension in the string. Now apply the work energy equation. The summation of all horizontal forces into S equal to, here actually W by 2G is a normal equation because here we have the two bodies, so W1 plus W2 by 2G into V square minus E square. By solving this equation, here both the bodies are started from rest, so the initial velocity is 0. So we have to find the value of V square is equal to 1.962 S. We don't know the value of S. Substitute this equation, the equations of motion as V square equal to E square plus 2AS. So by substituting I am getting here by equating those equations S's get cancelled and finally we have to find the value of acceleration A is equal to 0.981 meter per second square. Now we are going to find the value of tension in the string. Apply a work energy equation on any body. I am selecting the body at 20 Newton. So we have to draw the free body diagram separately for finding the value of tension. So for the body 20 Newton, the tension acts in the opposite direction. Weight is acting towards downwards and 20 Newton acts upwards. 0.3 into 20 as a frictional resistance force. So the work done is nothing but force into distance, net force acting on the body. What are net forces? Plus T minus 0.3 into 20 into S as the work done. We get T minus 6 into S as the first equation. And change in kinetic energy W by 2G into V square minus C square. We know the initial velocity is equal to 0. So by substituting these values, we know what is V square. V square is nothing but 1.92962 S. Just you have to substitute this value here, V square, and if I solve this equation, we are getting the value of T is equal to 8 Newton.